Welcome to this Artificial Intelligence for K-12 for Puerto Rico and U.S. Virgin Islands. This meeting will be recorded to have it accessible to other members that are absent today. The agenda for today includes attendance. I will put a link for the attendance. A welcome to all participants by Dr. Aratia. An introduction to our speaker, Dr. Selim Tezel. Conference about MIT App Inventor and other applications for artificial intelligence. We're going to have a small section for questions and answers and a feedback survey and alternatives. Right now, I'm going to leave Dr. Aratia, who is the gestor of this interesting activity, to give you some words before starting our presentation.
Okay. So let's see. Let me share my screen. I'm also seeing my, hello?
I'm sorry, Selim. I don't know if Dr. Aratia wants to say something before this meeting starts. Do you want to say something, Dr. Aratia? So, I'm sorry, Selim. Let me give him 1 minute. Okay. So I will copy the link to the survey, and this meeting will be recorded to have it available. Now it's my pleasure to present Dr. Selim Tezel from MIT Artificial Intelligence Group, who is a curriculum developer that joined the MIT App Inventor team a few years ago. And he is also a K-12 math teacher who has taught overseas. His goal is to bring MIT App Inventor to K-12 community and support teachers around the world. I am happy to present Dr. Selim Tezel. Welcome, and we are very pleased to have you here. Thank you so much.
Thank you very much. Let me share my screen. I'm also seeing my colleague from MIT, Jeff Schiller. Maybe he can also wave. He's a fabulous member of the dev team, and maybe at the end, he can not only correct me on some things, but maybe give us some insights into the machinery behind App Inventor. So I'm going to share my screen. Can everybody hear me okay? Because I had some difficulty earlier with sound. Are you guys able to hear me? Okay, that's great. So let me share my screen. All righty. Now, my name is, the lady was kind enough to introduce, is Selim Tezel, and my email address is giving there, stezel@mit.edu. I'm going to be talking about MIT App Inventor artificial intelligence projects today. And I have created some slides for you to enjoy at your leisure. And it is at that bit.ly address that I have at the bottom, bit.ly AI-MIT AI. Now, before I start talking about artificial intelligence with App Inventor, I just want to make sure that everybody's familiar with the App Inventor coding environment. So I'm going to very briefly talk about that. And if you're interested in later, I'm happy to do a live demo also. App Inventor is a completely visual coding environment. On the left, you see what is called the designer, where you have a components palette, where you have things like buttons, text box, password text box, slider, etc. All the visual components you would need while you're creating a mobile app. And as you're dragging and dropping them into the viewer here, you will see that in real time, you're going to see your app being built one component after another. At the very right here, there's a column called properties. And whatever component you want, you could actually change the properties. You could give it a certain text. You could give it a certain height, width, etc. Now, when you like the user interface you have created, you can go to this upper right corner where it says blocks. And when you click on that, it brings you to this interface here, which is shown on the right. which is the coding environment. Again, the coding environment is completely visual. It is blocks-based, so it's like putting pieces of a puzzle together. And the brilliant thing about it is that it is impossible, practically impossible to make syntax errors because pieces that don't go together will simply not fit. So this is a very attractive feature for beginning level coders. Now, I'm going to be talking about a number of tutorials in a minute. And if you go to our main website, which is appinventor.mit.edu, and you should scroll towards somewhere in the middle of that page, you're going to notice that there's a part called Artificial Intelligence with App Inventor, which will bring you to all of the tutorials that you can try at your leisure. Now, I want to roughly categorize the type of artificial intelligence projects that we have into two groups. The first group is called rule-based AI projects, and the second group is called machine learning-based AI projects. The first group, rule-based AI projects, are basically classical AI projects from the 60s, 70s, some new ideas, but this is where AI is given a certain specific rules and it executes these rules methodically. Whereas in the machine learning version of these projects, there is a training component involved. There are some statistics involved, confidence levels involved, which I will talk in a few minutes. The first example from the rule-based AI projects is called the Therapist Bot. We have a collaboration with a group called YR Media. You may have heard of them as Youth Radio. That was their earlier name. They published an article called "Could Your Next Therapist Be Your Phone?" So this project was inspired by this article, and it is based on the famous ELIZA project from the 1960s that MIT professor Weizenbaum has created that you may have heard about. The idea here is that the Therapist Bot uses what is called non-directive style of psychotherapy. This is due to Carl Rogers. The idea here is that the therapist never leads the conversation, but asks penetrating questions and guiding questions and allow the user to come up with their own conclusions. So here is an example of how the Therapist Bot works in the back. For example, let's say the user said something like, "I always loved my sister during the therapy session." The machine will start with a qualifier, will say, "Can you explain why," for example. And then the words "I" and "my" are replaced with the words "you" and "your," so that the question becomes, "Can you explain why you always loved your sister?" This will invite the user to continue with the conversation. This is one of the first projects. We had a context to introduce the dictionary data structures in App Inventor. Here you see first person pronouns, I, me, my, mine, replaced with you, your, yours, etc. And this gives a natural context for introducing these data structures and creating this project. The next project is called Voice Calculator. This is an introduction to conversational AI agents such as Alexa and Siri. We start understanding how do these agents interpret what you're saying to them, and how do they grasp your intent and are able to respond to you meaningfully. So, for example, in this project, when it's completed, the user of the app would ask a mathematical question such as, what is 73 times 51? And the app will parse the sentence, extract the numerical information, and figure out what the operational intent of the user was. In this case, it was a multiplication. And once it performs the multiplication, it will report again in spoken language that the product is 3,723, for example. So this is one of our first projects where the students create what is called voice user interfaces as opposed to graphical user interfaces. And it's a fun project. Just to give you a little bit of insight what is behind this, here you see many, many ways that a person can ask a multiplication question. What is 73 times 51? How much is 73 times 51? Compute 73 times 51, etc. What the app does is it extracts only the relevant parts of this sentence, gets the numbers, get the multiplication intent, and then will result with the product. Here you see the list structure, a list structure where the multiplication intents are listed, symbols and words in English that basically amount to a multiplication intent. The next project we have is called Rock, Paper, Scissors with AI. This project uses the context of one of the simplest children's games, Rock, Paper, Scissors. And what happens is you end up creating a program that allows the machine to observe and learn from the user's game choices. It uses what is called the Markov model, a Markov transition matrix. If you look at the lower right here, you'll see the matrix there. This is an example, an early example of what is called reinforcement learning. Now, just to give you a sense of how the machine does the learning, this is the Markov transition matrix. There are a bunch of numbers in the cells. So let's say the number 13 here. What this means is the user followed the choice of rock with the choice of paper 13 times. That's what it says. And if you look at this row here, you can see that most likely rock will be followed by paper by the user. So when the user plays rock, the machine predicts that most likely paper is going to be following next. Thus, to beat paper, the machine will say scissors. So it's a very simple learning scheme. And it's remarkable how quickly the machine will start beating the user in this. Now we start talking a little bit about machine learning-based AI projects with App Inventor. The first project we have is called image classification with the Look extension. Look extension basically classifies objects. It is based on a model that is already trained on about 1,000 objects from Google's mobile net. So when the app is completed, you would hold the mobile device to an object like a bottle or a lamp or a mouse, and the app will recognize this object and it will report the confidence level for the recognition. Now, it is unfortunately not very accurate. So if you show the mobile app an object it has never seen before, it is very likely that it's going to get confused. But this gives us a chance to discuss things like how AI algorithms may fail and how there could be bias involved in AI algorithms. The next project is called Personal Image Classifier, or PIC for short. This is inspired by Google's Teachable Machine. If you have played with the Teachable Machine, you'll find our interface very similar to that. Now, unlike the previous project, where the model was already trained by Google, this time the students trained their own model. It is an example of supervised learning based on inputting a lot of images. So here you see me at the left side capturing a number of images. So the first group is me showing my face, and the second group is me hiding my face with one of my or both of my hands. Once I'm ready, once I have given enough images, I train the model. And after a few seconds, you'll get a model that you can test with some fresh new pictures. So here you can see that the machine recognizes that this is a picture of me, of my face showing with 97.69% confidence level. So this is a browser-based training of models, and it uses Google's TensorFlow.js. Now, when the students have done the training, we have them build an app to play the game Peekaboo, such that when the user covers their face, the baby, an image of the baby is shown where the baby is crying. And if you're showing your face, the baby starts smiling. This is, again, a wonderful context for us to talk about confidence levels and also discuss what could be a bias in AI, because you can see that when you do the project, that it is quite easy to trick the algorithm. For example, if you're waving your hand back and forth, it'll get confused if it is seeing your face or not seeing your face. The next example is called Personal Audio Classifier, or PAC for short. This is very, very similar to the Personal Image Classifier. However, instead of training with images, this is trained with audio clips. And what happens is the audio clips are converted into what are called spectrograms that are visual, they are images. And thereafter, the project is a lot like the PIC project. It works with those spectrogram images. Again, here students will create their own models, and the app they end up creating in this project is a secret diary that only opens to the user's voice. If somebody else tried to open that, the diary will lock. The next example is PoseNet and Awesome Dancing with AI. Here we use Google's PoseNet, which is used to detect and track key points of the body, such as wrists, elbows, shoulders, etc. Using PoseNet, it is possible to create or construct a skeletal representation of the body, as you can see this on the right, where it can track some dance moves, etc. And in the app, while you're programming the app, you end up quantifying some basic dance moves. For example, having the hands in the air, or one knee up in the air, or doing a T-pose, etc. The app will recognize these moves and will add points to the score of a dancer. Now, these are the projects that are listed on that tutorials page. We have a few projects on the pipeline that I want to quickly mention. A project that is just about to come up very soon, as early as probably middle of next week, is called the Face Mesh project. This is very similar to the PoseNet project. However, instead of tracking the key points of the body, this project, we track the key points of the face. And in the app, it is used to create Instagram-like face filters. Here you can see the user use cat whiskers and cat ears as a type of face filter. And as the user moves around in the image, the filters actually follow her face, become smaller and larger, etc. Another project that we are working on, and Jeff might be able to actually give us some insight about this afterwards if he has time, is conversational AI and Amazon Alexa. Here, in the project, we interface with Amazon Alexa and creates apps that use voice user interfaces and conversational AI to understand the intents of the user. In this project, we utilize a feature called Cloud DB in App Inventor. This is one way that Alexa communicates with the app. And we're hoping that this effort will lead to an Amazon collaboration in the year to come. Another project that is very dear to my heart that I would like to see happen, but it hasn't even got started yet, is called GAN's Style Transfer App. And just it's best explained with an example here on the left. You can see the MIT Computer Science Department Stata Center, the building, a picture, a photograph of that. In the middle, you have art by an artist that you like, for example, Picasso. And what the app does, it transfers the style of the artist into the photograph to create a version of that image in the style of the artist. So here you can see on the very right, the Stata Center recreated in the style of Picasso. Finally, another project that we have been talking about is automatic text generation. It's called the Haiku Generator app. Here, we would interface with the user, ask some questions such as, what should be the setting of the haiku? What are some adjectives for the time and place of the haiku, etc. And when all is said and done, all the inputs are taken, a haiku is generated automatically. So this is something that we are hoping to make progress in the year to come. So these are some AI and ML project ideas we either have developed or are in the pipeline. If you have some AI ML project ideas that you would like to see developed in App Inventor, please feel free to get in touch with me, stezel@mit.edu. We love collaborating with K-12 educators, and it'll be wonderful to know you. Now, I'm going to stop the sharing so I can see everybody. I'm going to take a few minutes. First of all, if Jeff is still here, if there's anything that he would like to add, and definitely correct me if anything that I have not said properly. But Jeff is one of the geniuses behind all of the work that I tried to highlight. And he might be also be able to answer some of the questions that you have. Jeff?
No, I think we're just fine there, Selim.
I did not embarrass you.
No, you didn't.
Good.
You did great.
Super. Thank you. Super. So Juan, I'm not sure, how do we have people ask questions? Is it via the chat? You're muted, I think, Juan.
They can make questions over the chat, either in Spanish or English, or they can just unmute themselves and make questions.
And can I start? I would like a student to ask. You have any teachers want to ask student first?
Excuse me?
I'm asking the teachers would like to ask before we take over.
Right. I should also actually introduce, I just noticed that our project manager, Marisol Diaz, just joined us. Maybe Marisol, you'll be kind to wave. She, I believe, has some Puerto Rican background that she might be able to share with us. Actually, do you want to say a few words, Marisol, before any other questions?
Yes. That's good, Marisol.
Hi, I'm the project manager for MIT App Inventor. I am Puerto Rican.
That's beautiful.
And I have tried to reach out to teachers to do various projects in Puerto Rico. So that's actually one of my main pet projects to do, is to engage and to actually be able to do workshops in Puerto Rico in the near future.
Yeah. Okay, that's a great offer. Marisol. So we can accommodate that with a group of teachers here, and we can really do that. Okay. Yeah, because that was going to be my question. My question to Selim: how we start this the applications. Okay, but maybe you are there, so that would be fantastic, really. Okay.
What I can provide you, Juan, that I've done that with several other different folks and schools is we have a very nice sequential group of tutorials, because you can start App Inventor with AI, etc., and get really confused. But if you follow our, for example, Hour of Code tutorials, our YR Media tutorials, etc., it will bring you to a point where you can do some very sophisticated things. And I'm happy to share that sequence of tutorials that I would personally recommend if somebody wants to start from scratch.
Yes, I think that would be really good, Selim. I really appreciate that, because I think that would be the good way to do a project and implementation. And if we have problems, we just have your back in the program, or back in the people, and also Marisol can help us, right? Yes, to go forward. Yeah, we are going probably to do things in a different level with different teachers, because some they have some information, some they don't. So it will be different levels of how to implement it. Okay, so I think this presentation is clear. We can just follow what you are telling us, and also the tutorial will help us a lot. You see, so now it's my job to look for the teachers who are going to be working with. And we do have some administrative people that is going to help us just to do that. Okay, all right. Yeah, I'm not sure. There is some professors here who has student. Alvaro, do you have any question?
Yes, I have a question. There are experiments or some schools that are in some way implementing these activities, and what is the best way? Just to use them as block boxes, or really that the students begin to do their own projects, or what is the best approach?
So just to clarify, and maybe my colleagues can also, are you talking about specifically AI projects with App Inventor, or you're just talking about App Inventor projects in general?
Maybe AI.
AI projects.
Yeah.
So to be very honest with you, this whole page of tutorials that I talked about, it is only 1 year old. Like it literally started, we started a year ago. Wow. And we are hearing anecdotally here and there people using it. But it is at this point not quite a logical sequence of a curriculum yet. We are basically developing tutorials based on specific functionalities that are implemented in App Inventor. So you'll be among the pioneers, basically. If you end up using these, you will be among the first. Marisol and Jeff, please kindly intervene. Anything?
Thank you.
Yeah, that's good. Excellent. Fabio, all right.
Yes, good afternoon. Thank you for the conference. My question is about the how is the best way to share all applications that we could develop using artificial intelligence app of the MIT.
How can you share it, you mean?
Yeah.
So you can create an app that at this point in Google Play Store, you should be able to post it there. There are some work, and Jeff can tell more about that, to make the iOS environment also available for sharing apps. But anything that you create, can be created as a standalone and shared at this point in the Android ecosystem, and hopefully, early in the fall, maybe even in the iOS system.
Thank you very much.
One question that I have here, it is that do you have any URL or something that you want to share with us to integrate into classrooms?
Yes, so what I can do, and I actually, let me see if I can guide you into that by again sharing my screen so that I can show you how these things are accessible. Let me quickly, I apologize. Let me just get the, okay. So I'm going to share my screen so I can share with you the App Inventor website. So let me see. Let me try that again. Okay. So this is the App Inventor website, appinventor.mit.edu. If you enter into Google the words App Inventor, most likely this is going to be your first hit. And here, there's all kinds of information. For example, at the very top, you can there's a button that allows you to start immediately creating apps. There is an about menu where you could see our team members, learn about the App of the Month International Contest. You could read about our terms of service. But for educators, there's a part called Teach. When you click on that, you find the whole body of resources that are available. The first thing that comes here is called Computational Thinking Curriculum. And this is a freely available curriculum that can actually take almost a whole year to cover, that takes students from very basic App Inventor skills all the way to some very complicated and sophisticated cloud computing skills. So all of that is available here without any charge. And also on the main side, let me quickly show you. So everything I talked about today is in the middle of the page called Artificial Intelligence with App Inventor. So when you click on that, you'll come to all the projects that I talked about. But to the right of that is a part called App Building Guides. This is the Youth Mobile Power series that we have created with Youth Radio, with YR Media. When you click on that, you get a sequence of tutorials, which if you just follow in exactly the same order, it will take you as a beginner level, programmers. And really, by the end, you have some really, really advanced, skills as part of the coding for the tutorial. So I strongly recommend that you take some time on the website, and you should be able to see a lot of interesting things. And definitely feel free to contact me, Marisol, anything we can help you further.
Perfect. That's outstanding. Any other questions, guys?
So good afternoon. Thank you again for the presentation. So we are with two other faculty from the Virgin Islands, yes? And currently we are working, Michael and Aishi, well, we are working with the Department of Education. We try eventually to offer a dual credit program for high school students. So they can take a college level class and get credits in high school. And so we were using, we have two courses, computer science principle, and I think they're using App Inventor as well. So I would like to know if you have, in the new material you're developing for AI, what concept and map because now we were using a concept map to be able to provide computer science credit. Now, since we're introducing new concept in AI, we like to know what we need to keep, what we need to remove, so we can still map the curriculum to the AP course in computer science or computer science principle. So what you recommend to do the mapping?
Yeah, excellent question. So unfortunately, this is a little bit beyond my level of knowledge, but what I will share with you is the AP CSP, AP Computer Science Principle course you mentioned is called Mobile CSP. And it's actually, if you look at that Teach website that I mentioned, it's the second item that comes.
Yeah.
And what they have done is they have done all kinds of maps, etc. How the alignments are done with the standards.
Yeah.
Now, from what I'm hearing from those teachers, this AI curriculum is actually very new, even for that course. So most of them they were surprised by some of the work that we have done, and they were actually suggesting that they're going to take our tutorials, the AI tutorials, and make a recommendation to the higher ups in the mobile CSP administration so that some of these ideas can be applied.
Yeah.
So I think things are very much in flux and in the beginning stages. And I don't have a good answer for you. I apologize for that.
It's okay, because everything is new. So we would like to, because the teacher, they have plenty of work already. So we need to facilitate their approach. So we'd like to know eventually at the CSTA, Computer Science Teacher Association, if there is equivalencies where we can substitute a module by another one, maybe database with another one in AI instead. So yeah.
What I heard from some teachers, and this is, I mean, I used to teach, and this is really what I would do if I was teaching this right now. They said, they would finish all the material for the AP exams that they have to do. And then they have about a month of schoolwork, they still have to do. This is where they told me that they would probably introduce the AI topics. It'd be wonderful if it's eventually integrated into the school year. But at this point, there's this 1 month, which is not, it's not clear what to do in that month for some teachers, at least that's what I heard. AI tutorials are, I think, a good choice to fill that 1 month.
Perfect. So
I'm sorry. Go ahead.
So we maybe a good start will be to see what will be the minimum CS concept that they need to know to start the AI courses. Or did you think about what will be the minimum they should know before starting the AI? Yeah.
Our materials, I mean, they are mostly self-instructive, so we don't really assume too much background. The only background our projects assume, especially when it says intermediate level or advanced, is App Inventor background. So if your students already have done App Inventor for a number of months, it's okay to, for example, introduce something like voice calculator without having to do a ton of preparation, and because we sort of like do the needed background as part of the tutorial.
I think that we have excellent questions all over. And one thing that teachers are really struggle right now, it is that they need a base to be able to construct a course, not even in Puerto Rico, but Virgin Island, but other parts of the world. So they needed to have, some curriculum available so they can integrate computer science and also artificial intelligence. So I think that what you are doing right now is giving us the tools, but is from us, teachers that are all over, to try to figure it out about the resources that are online, which one we can use to build out the course. I think that that's why teachers are asking about manuals and the guides. What do you suggest that the teachers can start with right now so they can have, you know, like a basics and then go to artificial intelligence? I know that you said it already, but I just want to have at least something, a URL or something, so they can drive to that place. I don't know if you can help us with that.
Yeah. So if the students are at the high school level, especially, I mean, for App Inventor, the most, I think, sophisticated and well-developed curriculum is the one that the gentleman Mark mentioned a few minutes ago, is the mobile CSP. This has been developed over the years, and I think it's a wonderful introduction to, you know, programming, to App Inventor, and something like the AI projects I just presented could just be the ending of a course like that. Now, if you're interested in at the middle school level, that's the link that I showed you when you go to the Teach webpage. That whole year-long curriculum has been created with middle school students in mind. So that's the sort of the two paths that you can take. But it's okay to pick and choose. Some of those projects I think are so fun from the middle school curriculum that even high school students might enjoy them.
Thank you. Thank you so much. And do anybody has more questions?
We have another question. So when it seems that we rely a lot on the apps, on the technology. So do you have any, like CS, they have a CS unplug. So they have activities, computer science activity without using any technology, yes? So are we also developing in or some AI activity unplug? So the student now they can start thinking with a paper and a pencil, yes, to develop a system, but without programming first. Thinking about it, designing them, and then testing them using any tools. Right. I don't know if you are familiar with computer science unplug, when they develop activities on paper in the classroom. To teach them the concept, yes, of computer science, computational thinking. Are we developing also, or you think it will be important to develop AI activity unplug as well?
Right. So I think you're referring to the CS Unplug website. Am I hearing correctly? Yes. Yes. So if I was a teacher, that will be the place that I would start. Now, as App Inventor, we are trying to fill a specific niche, which is specifically mobile computing. So if we were in the business of creating a computer science curriculum from scratch, I agree with you. You have to do a little bit of unplug activities. You have to do a little bit of coding, a little bit maybe mobile coding, etc. But as App Inventor team, our focus is specifically, how can we introduce, these topics in the context of mobile computing. So because of that, we haven't really developed any like unplug activities, etc. But down the line, as this curriculum mature, there might be more of that, but not at this point.
Perfect. Okay, Elba. Any other question, Elba?
No, I don't have any more questions.
Okay.
Thanks, Selim and Dr. Laratia, for this initiative. Thanks to all for being here and actively participating in this workshop for MIT App Inventor and other applications for artificial intelligence. I think that this is wonderful to have you here and to share ideas and these URLs and also your knowledge about this App Inventor. I think this initiative is what we need to implement in Puerto Rico and US Virgin Islands as strong curriculum for computer science. And I think this activity and many others are informative and can be integrated into the teachers program that we have right now. Please use the form that I gave you to give a feedback about this activity and tell us if you want to have something like this or similar. And well, I just wish you to have a beautiful weekend. I'm going to turn off the recording so you can feel free to stay if you want, but it is okay if you want to leave. So have a wonderful weekend, okay? Bye.
Okay. Thank you very much, Selim.